Welcome to a slow, beginner-friendly lesson on building a small command line tool in Python, made for absolute beginners. Phase A.9 Capstone. Today is the capstone of Phase A.9. You build a small command line tool that uses everything you learned in this phase: reusable modules, type hints, the SRC layout, logging instead of print, configuration from environment variables, and clean error handling. The tool itself is small. The point is not the tool. The point is that you can read every line of it and recognize every pattern. By the end you will have a complete, structured Python program written from scratch. Everything comes together. Here is the project. A folder called mycli with the standard SRC layout. Inside SRC, the mycli package contains 5 files. Dunder init marks the folder as a package. Dunder main is the entry point Python looks for when you run with -m. Config reads environment settings. Logger configures the logging module. Operations holds the actual work functions. Tests holds the test file. This is the structure of every real Python tool. A real SRC layout. Create the project with uv-init mycli. Add python.tn for configuration and pytest as a dev dependency for tests. Create the SRC layout by hand, src/mycli for the package, tests at the top level. Add empty dunder-init.py and dunder-main.py files inside the package. The dunder-init marks the package. The dunder main is what Python runs when you use the -m flag. Add .tenv in pytest, copy .env example to .env and fill in your local values. Run the tool with uv-run python-m mycli. Pass command line arguments after the module name, --name eta to personalize the greeting, --upper to uppercase the result. The -m flag runs the package's dunder main file with the package context set up, which is what makes the relative imports work. -m on the package. Everything from this phase comes together in a single program you can run from the terminal. Many lessons, one tool. Before we build, recall what Phase A.9 covered. You learned how to split code into reusable modules and use the dunder name pattern so the same file works as a script and a module. You added type hints to function signatures. You organized projects with the SRC layout and dunder init. You replaced print with the logging module. You separated configuration from code using environment variables and the .env pattern. Today we use all 5 in one program. Recall the 5 patterns. Here is the program we build. A small command line tool that greets a name. It reads a default name and a log file path from a .env file. It logs every step at info level to a log file. It accepts command line arguments like --name and --upper to customize the greeting. It catches errors like a missing configuration value and reports them clearly. Small scope, but every part of Phase A.9 shows up. A greeting CLI, open config.py. Import os and load_.tenv. Call load_.tenv to read the .env file. Expose 2 constants with type hints. Default name is a string read from the environment, defaulting to world. Log file is a string with a default of app.log. Every other module imports these names directly. This is the single source of truth for every setting in the program. Read environment, open logger.py. Import logging and the log_file constant from the sibling config module using a relative import. Call basic config once with the log file path, the info level, and a format with timestamp. Create a named logger with dunder name. Every other module imports this logger, so configuration lives in one place and the logging calls stay clean. Logging setup is the kind of thing you write once and forget. Setup logging. Each module does one job. The main module wires them together. Small parts, clean connections, open operations.py. This is where the actual work lives. Import the logger from the sibling logger module. Define greet with type hints. It takes a string and an optional boolean, returns a string, and logs an info line on every call. Define parse name that raises value error when the value is empty. Notice the type hints on every signature, the logger.info call instead of print, and the raise for invalid input. Every pattern from this phase is here. The actual work. Wrap risky calls in try and except. Inside the try, call parse name and greet. If parse name raises value error because the name was empty, the except block catches it, prints a friendly message, and exits with status 1 using raise system exit. The status code matters when other programs or scripts chain off yours. A non-zero exit tells them something went wrong. The user sees a clear error instead of a raw traceback. Try and except. Python ships with argparse for command line arguments. Create an argument parser with a description. Add --name as a string option with help text. Add --upper as a flag with action store true, which means the value is true when the flag is present and false otherwise. Call parse_args to get an args object. Use args.name or the default name from config when the flag was not given. Argparse even generates the -- help output for you. Use argparse. By the end of the lesson you have written a complete, structured Python program from scratch. You can build this. Look at how the modules fit. Config reads the environment and exposes constants. Logger imports log_file from config and sets up logging once. Operations imports the logger and does the real work. Dunder main imports operations, parses arguments, calls the work, and handles errors. Each module has one job. Each import points in one direction. Nothing cycles. That is what well-structured Python looks like: small parts, clean connections. One job per module. Here is the full Dunder main file. Import argparse, the default name from config, and the functions from operations. Define a main function with type hints. It builds the parser, parses arguments, calls the work inside a try block, and reports errors cleanly. At the bottom, the if Dunder name equals Dunder main block calls main. This file is what Python runs when you type uv run python-mcli. Small, clear, one job the entry point. Try the tool. Run uv run python-mcli with no arguments and you get hello world, using the default name from configuration. Pass --name Ada and you get hello Ada. Add --upper and the greeting is uppercased. Cat the log file and you see an info line for every call, with the timestamp and the argument. The same code produced all three outputs. Only the arguments changed. Try it yourself. Pause and recognize every pattern. The Dunder name pattern at the bottom of Dunder main means the file only runs main when executed directly. The type hints on greet and parse name make the signatures readable. The src layout with dunder init.py marks the package. The logger.info calls replace print throughout the program. The config module reads environment variables in one place. Every idea from phase A.9 has a clear home in this small project. Every pattern has a home. Some habits that scale beyond this capstone. One job per module. Config reads, logger logs, operations work, main wires. Type every public function signature so the contract is visible. Handle errors where they occur, with a clear message and a non-zero exit code. Log meaningfully, an info line per major step, a debug line for detail, not a log call on every statement. These habits make projects that grow without becoming tangled. Habits that scale. A command line tool combines every pattern from phase A.9. Each module has one job. Config reads settings, logger sets up logging, operations does the work, Dunder main parses arguments and wires everything together. Configuration, logging, and error handling each live in their own place. The result is a program you can read end to end and write from scratch. That is the goal of this phase. Capstone in one breath. Congratulations. Completing this capstone means phase A.9 is done. You can write structured Python programs with reusable modules, type hints, clean project layout, logging, configuration, and error handling. Next is phase A.10, testing with PyTest, packaging your project so others can install it, and the professional practices that turn scripts into shareable software. You can build real tools now, and the next phase makes them reliable and shareable. Phase A.9 complete. If you want a quick practice, add a -- farewell flag. Add a farewell function to operations that returns goodbye name. Wire it into main so that when the flag is present the program prints a farewell instead of a greeting. Run the program with both flags and confirm the new behavior. You have just extended a structured program without touching the existing functions. That is the whole point of good organization. Add a farewell flag. Final self-check. Can you point to where each phase A.9 pattern shows up in this project? Can you describe the one job of each module? Can you explain why the Dunder name pattern matters at the bottom of Dunder main? Could you build a similar tool from scratch with a different purpose? If yes, you are ready for phase A.10. If any feels shaky, re-watch the matching earlier lesson before moving on. Say each out loud. Thanks for completing phase A.9. Next we move to testing, packaging, and professional Python in phase A.10. See you in phase A.10.